喂喂，喂，你好，大家能听到的吗？
Hi all, we'll get started in a couple minutes. Do we have Mikas in the bridge?
Yes.
Okay, so we're going to talk about VRRP today. We'll wait for a minute or two for the folks to join and then we can get started. Because probably you can start sharing your screen meanwhile, and we'll start in few seconds here.
Hey folks, hey Anya.
Hey Anzo, welcome back.
Thank you.
Just a few more minutes for the other folks to join.
So does Mika schema on this call? Okay. So he's
Yeah, he's already sharing the screen. Yeah, we're gonna get started. All right. Thank you all for joining. Let's get started. So the topic today gonna be virtual router redundancy protocol, and we have Mikas already sharing the screen. He will go over the PR. Over to you, Mikas. Thank you.
Okay. Can you see my screen now?
Yeah.
Yeah.
I can see.
Okay. Yeah. Good. Let me share. Okay. Thank you. So, hello, morning, afternoon, and evening, everyone. Today, I'm going to present the VRP adaptation for SONiC. And the scope is, or describes the high-level design of FR VRP adaptation to SONiC architecture. And so basically, this document will describes the high-level design details of VRP and its components adapted to SONiC infrastructure. And the VRP specifies an election protocol that dynamically assigns responsibility for a virtual router to one of the VRP routers on a LAN. And the selection provides two basic functionality. It will support dynamic failover in the forwarding responsibility when master become unavailable. That means backup router will switch to master's router and do the forwarding work if necessary. And the second, it will support load sharing among multiple routers by running multiple instances. And that means root can be master in one group and it can be slaver in another group. And we can control the load sharing by assigning different VRID and priority. The next session is about the requirement. And this design will covers below functional requirement. The first one, it will support two VRP versions, VRP version 2 for IPv4 and the VRP version 3 for IPv4 and IPv6. Second one, it will support configuration VRP instance on different type of ports, such as Ethernet, VLAN, and port channel. Third, it will support multiple VRP instances per device to realize load sharing among multiple routers. Next one is it will support configuration of priority for VRP instance. And the next one, it will support configuration of preemption mode for VRP instance. Next, it will support uplink interface checking feature. And the next session will provide some basic key information about how to adapt VFR VRP daemon to SONiC infrastructure. Currently, FR has already accomplished the VRP daemon process, and this implementation depends on the Linux equivalent devices to realize the shared virtual MAC among virtual routers. And suppose you have an interface ETH0 and they want to assign to one IPv4 address and one IP6 address to it, and you need to create a two equivalent device to ETH0 interface and set IP and MAC to each of them. And if you're using at least two, the configuration will be like these, like follows. Yeah. And a few things we need to take notice. These two interfaces are all left to the physical interface ETH0. Yeah. Any packets transmitted on this interface will egress via ETH0. The MAC address is set to the VIP virtual MAC, which was specified by the RFC for virtual root ID, for example, 5. And the virtual IP address must not be present on the parent interface. They should not be same. And the link local address on the interface is not driven from the interface MAC. Yeah, not the interface MAC.
Because few questions here.
Yeah.
Like by the point, like by the third point, do you mean in this VRP owner case is not supported, where interface IP and VRP VIP is same? Is that case supported?
You mean they should support, right?
Yeah, meaning VIP, can VIP be same as interface IP? In VRP RFC, there is a section called as owner, and that defines that interface IP and VIP could be same, and priority will bump to 255, something like that. That case, the owner will always be the master.
Yes.
Is that case?
Is the virtual IP is same with the interface IP?
Yeah.
Obviously support that, but currently we have not support. That's the future of the VRP owner, right? Currently we are not support. There are some issues. Yeah.
Issues in what section? May I know? Is it in a MAC VLAN interface creation or like FRR, VRRP? Where is the issue? Any idea?
Anybody can answer this question, because I have for some currently we found some issue about
Okay.
Yeah. Yes.
Okay. Also, a couple of questions like for the previous section. Do you support non-default VRF on the interface? Meaning, do you support VRF along with VRRP?
Sorry, not got your point. Can you repeat again?
Meaning, do you support the interface being in a VRF and running VRRP on top of such interface? Virtual routing and forwarding VRF instance. Meaning you can partition routing table and then every L3 component into different VRFs, right? Virtual routing and forwarding instances. So once interface is in VRF, do you support VRRP on top of such interface?
I think something we will discuss later. Yeah.
Okay.
Yeah.
Also, one more point here, please. Like meaning, SONiC supports sub interface as well. So maybe do you plan to support, or is it all this your VRRP? Does it run on sub-interface as well, or do you plan to support it in future?
Yeah, it support different type of interfaces, Ethernet, VLAN, and
Yeah,
tunnel,
but,
and so on.
but there is sub-interfaces as well, right? In SONiC, like so, can VRRP run on those kind of interfaces right now?
Yes, they are all supported.
You support? Okay. Because I did not see mentioning of it in the previous section, hence asking. Thank you.
Okay. Okay, thank you for questions. Next session about a functional description. We'll introduce some important behavior described by RFC and the list design. The first one is a protocol version selection. A list design will optionally specify the protocol version 2 and the version 3. And if the protocol version is not specified, the default is version 3. Note that version 2 does not support IPv6. So any IPv6 configuration will be rejected when the version is set to version 2. And the next one is the preemption behavior, and which will allows backup routers with higher priority to take over master status from the existing master. And it is enabled by default. And of course, master ship switchover will cause some unnecessary temporary network disruption. And the third one is the virtual root owner, and it is the instance, or can also be called group, whose virtual IP is same with the interface IP, and it will have the highest priority and will preempt the master role, no matter the preemption is enabled or not. This is described by RFC. And then the next one is virtual MAC. And the following virtual MAC address used by the protocol for IPv, they are formatted by a prefix and a virtual root ID. And for IPv4, this byte is 1, and for IPv6, this byte is 2. Yeah. And the virtual root ID has interface scope. That is, virtual root ID has to be unique among the instance on an interface. Next one is advertisement frame. The control packets IP protocol type is 112. Yeah, and the destination IP address is multicast address 224.0.0.80. And the source MAC address is a virtual MAC address, and the source IP is the interface IP, yeah, not a virtual IP, and it will be effective among virtual routers. Next is uplink interface checking feature. Yeah, the fourth point which VRP safeguards against this, the interface on which VRP instance is present. So even if all the connectivity of the master to the external network fails, it will still not trigger the failover to the backup gateway. So uplink interface checking feature has been introduced in this design to overcome this limitation. As shown in the figure, VRP backup groups were configured among root A and root B. And both of them will operate in preemptive mode. And on root A, interface 1. Interface 1 will be configured as uplink checked interface. And when the interface 1 fails, root A will decrease its priority. And the little b will do the preemption and it becomes the master to make sure the traffic will be forward. Next session will talk about the architecture design. This feature does not change the existing SONiC architecture, but introduce some new processes in existing container to handle the logic to fit the RFC requirement. In order to enable the FR VRP function, so it is necessary to configure the corresponding Machiavellian device externally on FR to implement the shared virtual MAC function of the protocol. Considering the overall architecture, it has been decided to add some process, for example, VRP manager daemon, VRP syncd daemon in BGP container, and the VRP all change in SWSS container. And the below diagram illuminates the interactions between relevant components and the database involved for VRP future in SONiC architecture at a high level. And VRP will components extend functionality. Yeah. Implementation from the existing FRR design. FR configure demo will be run to listen to configure DB. When the field FR manager framework configure field is set as true, or otherwise the VRP configure demo will be run instead. That means FR configure demo or VRP configure demo will configure FR VRP by using FR CLI command VTYSH to set the configuration to VRP demo.
One second. Okay, why are we?
Okay.
I don't understand this check. Can you come? Can you go down a little bit? Can you go down? So you have all the VRRP configurations in the config.db, right? So which means like we can so have this FRR management set to true, and then in the device table can be used for the VRRP configurations as well. Because when you, if you, for the false case, we expect to run BGP CFGD. So if you have all the configuration, FRR configurations in the config.db, so the right way to handle is, enabling FRR CFGD. So I don't know what is this VRR PCFGD right now here.
Yeah, I also don't know why they are conflict. The VRP and the FR conflict, why they are conflict.
Yes, both should work. Yeah, VRRP configuration can very well be handled in the FRR CFGD itself.
So you
I have another question. I think I remember usually the VRP manager D and sync D, they should be in the SWSS container, not in the usually not in the like the BGP container, right? So that's the first thing I think.
Yeah, that's correct. Yes.
Yeah.
Okay.
And also, why this VRPD has to be on the BGP container? Why cannot be on a separate container?
Because it is a component accomplished by FR. Yeah, already.
Yeah, but it's
and
it's
we
a
want
separate
to
process,
use
right? So.
Zebra. Yeah. Because the Zebra demo is running in BGP container. Yeah.
Yeah, but you can also you know what communicate channel do you use for Zebra? Maybe you can expose that socket channel, for the BGP container to the.
Yeah, good.
So on actually the VRP is coming from the FR community, right? So it has the BGP Docker.
I think to extend Wuhan's discussion, so the VRRP need not to be achieved via FRR, right? So it can be achieved via some application like TPLID, and in that way, it can need not to run inside the BGP container. It can be a separate container and using the TPLID to achieve the same thing. So all the priority, etc., can be achieved through the TPLID, and VRRP can be a separate container. It can come out of the BGP container, and FRR config change is also not required in that case.
There was one VRRP HLD PR already in the community done by Broadcom long time back. I'm not sure about the status of that HLD, and that HLD talks about the use of keep LFD. I would like to see what are the differences, or like what is the advantage that you are bringing in with respect to the old PR. And even I request community members just to have a look at it. I put a comment in this PR right now to reference back to the old HLD.
Yeah, thanks, Fanny, for bringing up. So in fact, yes, there was a earlier VRRP HLD post in 2019. It actually gone through a couple of reviews, and we will be refreshing the HLD to incorporate the latest of the comments. Also, there are minor updates that we want to make. But I think the design concept is, a little different from what here has been presented. We will have in the original HLD, we have a VRRP container separately. And, a couple of questions that Vijay has asked was actually taken care of. For example, multi-VRR support is actually there in the early HLD. So, yeah, so please take a look. And then I think I at some point in time, I think we should talk about how to converge the two HLD.
Yeah, I think
thanks.
Adam, we should converge on that, because this is like two different design for the same feature. So
Yeah, absolutely. I think we should have maybe a breakout group or a subgroup to carry on the discussion to find the best way to implement from both. Yeah.
Is the premier feature upstreamed or?
No,
I
no, it's not. I mean, the code has not been posted. The HLD was there, and it received.
No, Adam, which LD are you talking about? Can you share the link?
No, hold on, Yanzhao. No. Hold on. Sorry, Adam. I think this may not be a good thing, right? So if we say we have HLD that been published in 2019, but there's no activity, to upstream it, then I'm sorry. I don't know how to interpret this, right? So I think we should have whatever it shouldn't block the future community efforts here, right? So
no, actually not. No, we're not saying we should block. I mean, as a matter of fact, the HLD was there. It gone through a couple of reviews, and we haven't posted code yet. But I think the concept of the design is actually quite different from what is being presented here. What I'm asking is, we should probably take a look at that also at a subgroup and see how the two design can be converged, so that the two teams can agree on how to contribute to the community in that sense.
Yes, we can discuss later about the old HLD. Yeah, but I think the high level server are different. Yeah, one is keep activity, and then this one is implemented from FRR component.
Yeah.
I think the discussion is mainly towards why it cannot be a separate container, why it needs to be inside the BGP container. That's why the old PR came to the discussion. So before discussing too much inside the BGP container, I think we should converge on the other approach as well. plus this, and then
Okay. So I think I can go on, right?
Yes, please continue.
Okay. High-level design, yeah. Since the supporting for set Macmillan device into protocol down state was not added to kernel until version 5.1, so the kernel version needs to be bigger than that. Yeah. The max number of instance for IPv4 or IPv6 instance number is 254 due to the limitation of the 1 byte virtual root ID, which is used to format the virtual MAC address. And in BGP container, below process will be added. Yeah, first one is VRP configure daemon. It will subscribe to configure DB tables and passing configurations and pass them to VRP daemon by using FRR command VTYSH. And the VRP daemon, it is responsible for RFC related protocol logic. And the VRP packets are sent and received in VRP daemon, and the states are updated accordingly. And the VRP management, it will listen to VRP it will listen to configure DB for VRP instance creation, deleting, and parameter changing, and will complete the following tasks: add a dear Macmillan device to kernel, and configure virtual MAC to a Macmillan device, and add a dear virtual IP to Macmillan device, and update the VRP instance configuration to the APPDB. And the VRP syncd will listen to a kernel Macmillan device and the other interface protocol states change events, and will update the kernel Macmillan device status to the APPDB, and it will also do a monitor uplink interface to see if needed to notify master root instance to switch to backup state. And in SWSS container, VRP auto engine will be added. It is subscribes to APPDB tables and response for creating, deleting virtual root interface object via SciAPI. And the list design implements the forwarding function for a VRP service using a virtual root interface object, which only process the ingress root MAC. As Sci performs special resource optimization on the virtual root object, Sci requires that the features such as admin state or MTO size or packet forwarding action and multicast enabled cannot be configured on the virtual root interface. That means when you want to forward to server and set the admin down to ask for the virtual root interface, that will not work. The forwarding plane is still active. So to resolve this problem, VRP auto engine will delete the corresponding virtual root object when the VRP instance is down, and will recreate the corresponding virtual root object when the instance is up.
Hey, I have a question on the SWSS part. Is VRRP model need to be known at the SWSS layer? Like if it is only creating interface or deleting interface, can we reuse the existing interface model?
Mm,
Can you hear me?
yeah, I have another question. I think your question is why add or remove, not set admin down, right?
Yeah, something like that.
Yeah, because we will set and we will discuss later for the site API, because we will set a field. The field is, I remember, is this one. Add this field, side root interface attribute is virtual, yeah. And when this field is set to the root interface, some action cannot be performed on the virtual root interface object. So we have to add them or remove them when the protocol is up or down. Yeah.
No, I saw the Prince. Your question is more than that, right? So I saw your question is about, do we need a VRP specific org, or we
That's
can
right.
use existing
Yeah,
org if
okay.
we just yeah.
Yeah, that's right, Gohan, because VRRP is a notion not known to the basic or
Yeah,
right?
we
So
have considered that, but I think it's more convenient first, right? Second, there's some difference between common root interface setting, yeah, because logic may be some differences, and another reason is for extend compatible, right? I think we will do some other VRP enhancement later on maybe phase 2. So I think a VRP auto engine is better.
okay, yeah. So I think I'll take a look. Yeah.
Okay, thank you.
Philu, like one more question here. Can you go up, please, into the diagram? Little up. Yeah, little up. Yeah. So here, like VRRP synced, right?
Yes.
It seems to listen to kernel, and then once again, like for track interface, like it is feeding the VRRP through the configuration, right? Meaning up for the track interface up down. Maybe that might not be an optimal way. Maybe we might need to provide the interface status directly to VRRP, not through configuration. Maybe in FRR, maybe you might have a component like a Zebra talking to kernel. Maybe it can, maybe that kind of component needs to interact and then feed the interface state directly to VRRP and then set the tracking priority. Maybe tweaking the configuration is like sounds little different. And then yeah.
This is one of the optimization present in the Broadcom sphere, where this kind of tracking interface notifications directly people ID informs the VRRP CV.
Yeah.
Rather than listening to the kernel. So the other design of running the VRRP container with the people ID instead of FRR. So that design has that kind of automation as well. Like I think Venkat has posted the link to the PR link in the chat window. Yeah, please take a look at that design as well.
Yeah, meaning what I meant is like the interface state maybe can be directly fed to VRRP without tweaking the configuration. Yeah.
Yeah, the tracking interface based on the uplink interface down, right? So the tracking interface priority changes. That kind of notification is calculated by the keeper ID itself and then notifies the VRRP CV for further action, rather than listening to the kernel events as shown in this design. So if you take a look at that design, you will see a separate VRRP container where VRRP config and the people ID and CDs running inside together, and also takes care of programming the kernel, and then the notifications are coming from directly from people ID.
Sure. Okay.
So it's better take a look at that design as well. I think we should take a look at that as well, and see how we can progress further on code merges, etc.
Okay, sure.
I think Vijay's point here specifically is about this implementation where the uplink tracking functionality should come from the FRR rather than building it outside of the VRRP component.
I think yes. Currently, it is not implemented by FRR. Yeah.
Correct. So I think it should be an enhancement done in the FRR community rather than building it outside, right?
Yeah. Yes. Yeah. Good question. Good suggestion. Yeah. Okay. Next is about COPP configuration. COPP will be extended as far as to for trapping VRPs. Yeah, CR is set to 300. It is in order to guarantee 1 packet per instance per second. Yeah, because the max number of instance is 254, right? 300 is enough. And the trap action is set to trap, and the priority set to the highest 7, right?
So is COPP enabled by default, or how do you plan to enable it? Is there a associated feature table?
You say set defaulted, right?
No. COP can be enabled 2 ways. One is you have an associated feature table where if the feature is enabled, the COP entry will be installed. Otherwise, there is a field called always enabled, or can you scroll down? I think there is a specific table for always enabled, yeah. Something like that. So you are enabling it by default. That means the platform should always support VRR. And I don't think this is correct, right? You need to enable it only when you configure VRR.
Yeah. It can be controlled by configuration, I think. Yeah.
Okay. Can you make sure that you, when you only enable the VRRP, you make the always enable to true?
Make everything to go, right?
No. When only VRRP is enabled, you set the always enable to true. Otherwise, the VRRP trap will not be installed. That's what I'm requesting.
You mean when enable the future, everything will up, everything will be okay. If it is
No, I mean in the configuration file, you should not have always enabled. You should remove the always enabled from here. And when VRRP is enabled through CLI, only then set the always enable to true. In this way, VRRP is not enabled by default, the COP for VRRP.
By default, disable.
Yeah. By default, it should be disabled. Yeah.
Okay. I will take a note. Yeah. And the next session is about the DB changes. And we will add the VRP table in configure DB to store the protocol configuration. The consumer will be VRP manager demo and the VRP configure demo or FR configure demo. The key is formatted by interface and the virtual root ID. And the interface should be the one which virtual root ID is level 2, as we mentioned before. Yeah, virtual root ID stands virtual ID. Yeah, virtual IP stands for virtual root IP, and the interface the priority will be used to for the judgment of master switchover, and the advertisement interval. The default value is 1 second. Yes. 1 second. Preempt were set to enabled by default. And the check interface stores the list of interfaces checked by the VIP instance. And below shows an example of config DB. And we will add the VIP table.
One question here, like what is the meaning of state here?
Yep. Instance, yeah, VIP instance, up or down.
Instance,
Yeah.
up or down?
Yeah.
And this is config DB, right? Okay.
Yeah, it has
No.
have another meaning, not the protocol down. Yeah. When be master, instance be master will set it to on. Right? When be backup, it will set to down. Yes.
No, the question is this is a config DB table schema, right? So why is the state there in the config DB?
Yeah.
Is it like, should it be there or not? That's a question.
Let me check.
I'm seeing a lot of similarities between the schema from the old PR to this PR. So, I mean, did you leverage anything from the old PR, like, or? But anyway, I guess it's just a note to the members. Basically, I left a comment in the PR with the old with the old reference. Just have a look at it and see what can be leveraged. Thank you.
Yeah, I will check the comment, and I will check the state meaning later. Yeah, I need to check this one. And for AppDB, we will add the app VIP table, and the producer is VIP manager demo and the VIP SIND, and the consumer is the VIP auto agent. The key is formatted by interface name and the virtual ID and the type. The type stands for IPv4 or IPv6. And the most important field is the virtual MAC. It stands for the MAC address. We need to set to ASIC chip. Yeah. Here the state is up and down. And the below table shows the example.
Here one question. What is the use of priority in that VRRP table? Will the VRRP org use it anyway?
The first is the value is set from the config DB, and the second one is it will use as a temp the value to calculate the priority and set to VIP demo. Yeah, for master switch over. VRBD use it. Yeah.
I mean, the
Yeah.
consumer
I think
of
the
it
question
is
whether that priority is used by the org agent. Is it used or?
who is the exactly like who is the consumer of that data? And
VIP sync the D is the consumer, right? Consumer VIP all change. Let me check.
Will the forwarding entries be installed based on the priority?
I think
I think the question is around
consumer.
the area where
VRP config D. I
No,
think,
I think that attribute we can remove it from the application DB because only the VRRP DB alone needs it, right? So config DB alone can have it for VRRP D to consume and decide the like master slave thing. VRRP arc agent need not to know about the priority. So the table is fine, but this field need not to be there in the application DB and the arc agent need not to be care about it. I think the discussion is going that why arc agent need to know about the priority. You can remove this field from the application DB. You can keep it just in the config DB.
yeah. Okay, we check about this.
Also, one more question here. Like in the VRP table, is there the virtual IP configured? Meaning, how is the org agent notified about the virtual IP that needs to be installed as my IP in the hardware? I don't see VIP here.
VIP is here. VIP, yeah, with VIP.
In the example, I don't see.
Yes.
It's captured in the config DB table.
Yeah, her config table has some virtual IP, but here, let's see this one. Also, I think I need to add this IP.
You are referring AppDB, so I think it is part of config DB.
Yeah, config DB has virtual IP. That's correct. But why? Here I need to check. I think here should add has this field about IP, which IP. Yes.
Okay.
Okay, thank you. And then for SDB, and there's no new table or schema change. And the below table shows some fields value of the virtual root interface for VRP. And we'll add a new field and set the value to true. The new field is side root interface attribute is virtual. And next is about module design workflows. The first flow diagram describes the work sequence of VRP instance adding and removing. And the CUI will add a deal VRP instance to configure DB. And for FR data plane, a VRP configure demo will listen to VRP create, delete, and the parameter change event in configure DB. And set the parameters into VRP demo by using VTY SH commands. And then VRP demo will run VRP state machine. And if the state machine transistors to master, will set the MacVision device protocol down state to off. And if not master, will set the protocol down state to on. And for SCR and the kernel data plane, VRP manager demo will listen to configure DB change and add their VRP instance corresponding MacVision device to kernel with IPs and status. And we'll update the virtual VRP instance configuration to AppDB, such as the name, the VR ID and IP address type. And the VRP sync D and is responsible for syncing MacVision device protocol downstate from kernel to AppDB. And the VRP change and will listen to VRP table in AppDB.
Can you go back to your AppDB schema?
Yeah.
So there is this in the key. There is a field called type. It says IP address type is V4 or V6. Oh, what does it mean? Like, are you carrying the IP address part of the key, or like So it is related to the earlier question. So you have key has 3 fields: interface name, VRID, and type. And the type says it's an IP address type as string v4 and v6. I'm not sure how that is used here.
Yeah. I think this table I need to check for this APP table after meeting about this table. Yeah.
Because the IPv4 and IPv6 have a different interface for the size, so we need the type to determine which interface we should operate.
Okay.
Okay, thank you. Thank you, Patrick. Yeah. The second flow diagram will describes the work sequence of uplink interface checking. And the VRP syncd will listen for interfaces state change events notified by the kernel. And if the checked interface goes down, the priority of a VRP instance will be reduced by weight, or other will are added by weight. And then once the VRP demo got a priority change event, will update the VRP packet priority field. And if master instance priority is smaller than backup instance, then we'll do master switch over task and send a notification to the peer. And the next for SciPI.
Is it not taken care internally in FRR, like when the interface goes down, role change and all those things? Why do we need to update the priority?
Yeah, we want the master to do switch over favorable task. Yeah.
That is based on the uplink interface tracking feature method. So the tracking interface, those are the uplink interfaces we use to track. And once those interfaces goes down, so the priority needs to be updated accordingly for the role change. That was the one we spoke at the start. The FRR doesn't have the uplink interface tracking feature.
Okay, this is with the uplink interface. Okay, got it.
Okay.
Yeah.
And for SciPI, there's no change for SciPI, just add a new field. Yeah. And next is a configuration and the measurement.
Is this Psi attribute is available in the community, or
yes,
are you
already supported? Yeah.
Okay.
Yeah, no change. And the next is for YAM model. Yeah, this is YAM model.
No, sorry. I think the question is more than that, right? So the API is defined in the site, but doesn't mean all the vendors support the API, right? So therefore, I think you need to, if you want to use this attribute, you have to query it and to know whether this is supported by a specific site vendor or not.
Yes. The SciPI is supported, but if vendor implementation, we need to check, yeah, whether it support actually or not.
So how do you plan to do that?
I need to think, but currently we just need to call the API create a root interface, right? Yeah.
Okay, so you need to have an item to describe, okay, what if the site implementation doesn't support this attribute, right? So
okay.
There is not much difference for the hardware if with or without the virtual attribute. So if some platform not support, I think we don't add the attribute when Psi calling.
yeah, I think I'm okay with that, but I think it should be described in the HLD.
Okay.
Okay, next about Young API. Yeah. Interface name support and VID virtual IP priority and advertisement interval, state and version and preemptive mode and check-it interfaces. And for CI,
one question, one suggestion here. Yeah, maybe you can check if the state is needed or not in config.db. And the next one is like the track interface list, right? The key seems to be a string. And then maybe like we have features like breakout port, etc. For those kind of features to be supported, maybe there should be a reference for these interfaces, track interfaces, and maybe it cannot be a string. Maybe it needs to be interface type. So maybe please revisit the data for tracking interface.
okay. Okay, thank you. Thank you for your suggestion. Yeah.
Thank you.
And next about this CUI command. Yeah, for we support below list below table shows some list of about the configure command and the show command. First, due to time reason, I will not introduce one by one, right? Configure instance add, backup forward, yeah, and virtual IP add on moving, priority setting, advertisement setting, preempt mode setting, check interface at the end removing. The show command shows an example about show interface or show summary. And the for one reboot counter we will not support it because when do master switch over will cause interruption, flow interruption. So we will not support at phase one, right? And the restriction and limitations can't not support virtual router owner, yeah, as we mentioned at first. And the accept mode cannot configure currently, yeah, or about the virtual router owner, same future, I think. And the test case will cover below test cases, configuration test cases, ping, and some L3 forwarding, and the sharing, and the uplink interface checking. Okay, I think that's all.
Oh, thanks. I think, you know, I think this is a good discussion. I think people are putting comments. Maybe you can look at the comments and
I have
address them.
seen many comments. Yes, thank you for.
Okay. And I think there were some, you know, old design, you know, the keep live D. Maybe you should also take a look at that. And I think this proposal probably need to further discussed in a subgroup. I think this is more like a layer 2 subgroup that we're you know, we're going to create, and maybe we can do a more deep dive in that subgroup meetings to further you know, close all the issues on the HOD and then get signed off.
Okay.
Yeah. I think we'll send you more information about the, you know, the subgroup creations. Thanks. And
yeah. Go ahead.
yeah, I don't know if did we discuss there was an email that were sent out for the you know, 2023 the bookworm upgrade for the Debian bookworm upgrade. I don't know if we briefly discussed that with the community, you know, the timeline and those kind of things.
I don't think
No,
so.
I don't remember. Yeah.
The discussion.
Okay. All right. So yeah, I think you know, I send a message in the chat window, and I think we'll ask the, you know, there was a Debian working group
recently formed in SONiC community that is driving the SONiC base image upgrade. I think there have been discussion around for the 2023-11 image. We're going to upgrade the image to Bookworm,
The
which is
Debian version.
Debian, the Debian 12. So there were a few dates, kernel, the base image and all the drivers. And please, folks, to take a look at that message, and then plan your if you platform owners, you need to plan for your driver upgrade. Yeah. So.
I think another one is like a heads up. So as you may already noticed, we have far more candidate features than our community slots. So that's why the TSA is proposing a new approach to review the new features. So I would call this like a lightweight and also distributed approach. We will leverage more on the subgroup. So today, just a heads up. So I will share more details later once we have locked down the solution. So I think that's all for today's meeting. Thank you, folks.
Thank you. Yeah.
Thanks.